Hello, my name is Carsten Rossenhövel. I'm the CTO and co-founder of EANTC, the European Advanced Networking Test Center in Berlin in Germany. And it's my pleasure to introduce you to the end-to-end testing challenges and innovations in 5G in this session. So at EANTC, of course, you know us best from the conferences in Paris with our transport interoperability showcases, but we have always also looked at the services in 5G and in fixed networks. We are looking also even more and more into the application requirements in 5G. And so I'm going to talk today about all of the different domains of 5G testing, because it's much, much more than just looking at the evolved packet core these days. So we have had backhaul transport as one area of testing. That's something we have been covering, and I'm going to explain the challenges in this session. But more and more, we also have front haul and mid haul testing requirements, not only, but mostly now that disaggregated RAN in multi-vendor environments are coming up. So all of the open RAN requirements are quite challenging, and that's one of the important development areas in 5G testing. And then last but not least, of course, we have virtualized platforms with NFV or telco clouds that have been around for 8 years, meanwhile, if I remember correctly. But still, there are a lot of challenges, especially in achieving the right performance on the platforms. And no service can be better than a platform it's provided through. So that's also a very important 5G testing domain. In all cases, it's very crucial that the testing goals are aligned with application use cases in 5G. In the past, even up to LTE, it was just, a data stream more or less. But in 5G, there are so many different types of application use case requirements. They definitely need to be taken into account per vertical. So we have public protection and disaster relief, of course. We have automotive scenarios, railway, healthcare, industrial IoT, factories being connected over 5G and so on. And each of those has different requirements for the network and for the application performance that need to be taken into account for testing. In the end, in 5G, we have a complex multi-vendor scenario in almost all cases that has more vendors and more components than ever before, and more software components than ever before. All of this, from our point of view, from EANTC's point of view, requires more automated, more regression testing, more frequent testing to be recurring not only at the beginning, at the inception of the technology, or at the purchasing and deployment of a specific solution, but throughout the whole network lifecycle. So in the diagram, what is the 5G testing coverage? So on the top level, you can see the red arrow here reaching from the far left to the far right. And these are, of course, the applications. The applications are on top. For those, the network is mostly a black box, but in the end, they get KPIs, key performance indicators delivered by the network, and they have certain requirements on these KPIs. These need to be taken into account. For example, sometimes you have very low latency requirements. Sometimes you have high throughput requirements, but for example, in an industrial environment, it's most important to have a super reliable network that never fails. So all of these requirements are application domain specific, and they need to be taken into account. The next area is the network management and orchestration, which is coming from the traditional OSS scenario, which was single vendor orchestrator talking to single vendor routers and equipment under control. But this is also opening up. So it's another area of challenges and innovations. Then the blue arrows here are showing the different parts of the actual 5G network service through the 5G core and internet access, of course, but also mostly the Open RAN and xHaul connectivity, as I said in the beginning. So in the Open RAN, there are multiple components: the open radio units, the open distribute units, the open centralized units, and also the radio integrated controllers, which all have some kind of networking in between. And they all are usually coming from different vendors in an open market and need to be tested for integration. Then on this level, we can run a benchmarking of network level KPIs, traditionally latency, throughput, and other things. And finally, in the bottom, as the delivery chain of this whole ecosystem, we have platforms. And the platforms are almost always virtualized platforms these days. Of course, some vendors are still running their software on bare metal servers, but in most cases they're virtualized, they're containerized, and they need to be tested for integration. And there are complex interdependencies between the hardware, the host OS, acceleration and FPGA cards, the application software, clock synchronization attachments, and so on. They all need to be taken into account. And only if all of this is understood together, then the 5G network and application can actually successfully be deployed. So starting with the transport network in a bit more detail, what are the actual challenges? Of course, one of them is we have a much higher density of base stations and antennas. Of course, we have a much higher expectation on data throughput from each consumer endpoint. And all of this increases the scalability requirements for the transport network. And all of this also increases the number of network nodes in the access and aggregation network. Specifically, if we're thinking about millimeter wave, we will have an order of magnitude more network transport equipment in the whole ecosystem. There is a major architecture change in the EPC, in the Evolved Packet Core, that now that we see NFV-based microservices architecture. So in some cases, service providers have even announced that they're going for a fully cloudified architecture. So these are also changes of the virtualization layer. And we see all of these very diverse service requirements in different slices. So each sales site now needs to support multiple slices with very different requirements, some of them with ultra low latency, some of them with very small flows, for example, for IoT, minimal amounts of data happening only once in an hour, and some of them elephant flows of augmented reality, virtual reality, 4K data streams. The network upgrade is not trivial, especially going from 4G to 5G. What we're seeing right now is only halfway the transition, because most operated production networks are now at the so-called non-standalone stage, where 4G and 5G are closely coordinated with each other. And then the next stage would be to go from NSA, from non-standalone to standalone 5G networks, where the architecture has to change a bit again. And of course, for the transport, some of these older generations of mobile networks need to coexist. 2G will probably continue for a long time, LTE will continue, and there are also handover requirements. So each of those kicks off a different interconnectivity requirement. So at EANTC, we're doing transport interoperability testing, and let me start with that because this is an activity that we published right specifically for this conference. So our latest round of X-Hall transport testing has just been finished, and it's our pleasure to publish a white paper at the occasion of this conference. We have actually covered policy-driven slicing transport, especially with Flex Algo, a very modern, innovative solution that's standards-based and works in multi-vendor environments and allows automatic deployment of policies. We have also tested advanced clock synchronization for very high precision clocks with more than 260 nanoseconds precision, or actually less than that. And we've also verified front-haul physical connectivity options with Flex-E, a new technology for Ethernet and sub-Ethernet based slicing. So the results are published here. We had 10 vendors participating this time. On the right-hand side of this diagram, you can see the topology of this year's event. And it's definitely non-trivial. We ran through more than 500 test combinations in only 2 weeks of testing. So please, if you're interested, read the details. The second publication that we're sharing at the occasion of this conference is the white paper of our results of the NETCONF and Young-based SDN management interoperability test that we conducted in April this year. And here we focused specifically the interoperability of NETCONF and common and proprietary Young models between the participating vendors. We focused on device configuration, of course, but also on service provisioning for VPN services for layer 3, which could also be used as the transport for slicing in 5G. And the insight is quite a bit on what is possible with NETCONF today, what is not possible, what needs to be improved on the standardization side, what needs to be improved on the implementation side. But I think we will definitely continue this series of interoperability events. And we see a lot of potential here for true multi-vendor standards-based orchestration. Going to research where we're participating, one of the projects where EANTC participates, it's now in the closing phase, is 5G Winnie. So over the last 4 years, we've worked together with Telenor, with BT, Telefonica, to actually validate the multi-vendor testing requirements, cross-site, cross-operator of 5G deployments in each of the sites that are marked in green color here on this diagram. There were mobile cores and access networks deployed, and we were responsible for defining standardized test tool interfaces and test methods, together with Keysight and other partners, vendor partners, of course. So the results are now publicly available, and I'm recommending that you might want to look at 5gwinnie.eu. Another area where we're very active, of course, it's in our home turf, is 5G Berlin. We have co-founded a non-profit organization bringing together all of the academic and industrial partners for 5G research and deployment in Berlin. So partners are Fraunhofer Institute, universities in Berlin and around, and small and medium-sized enterprises in the Berlin region. And our goal is to create an urban outdoor test bed at the TUB campus that you can see on this map here. So this outdoor campus is able to test the applications, whether they are drones or IoT devices or whatever kind of outdoor applications. And we are going to put a special focus on these application requirements and also on the optimization of the network resources that are now coming with the real-time integrated controllers. So one of the parties here is specifically investing into research of AI-based optimization of the 5G network. Furthermore, now going to the front hall, we have actually participated and co-organized the second joint European O-RAN Alliance and TIP Plugfest for Open RAN last year, and we're now in preparation of the next one that is going to be completed by end of November this year. These Plugfests are hosted by Deutsche Telekom in Berlin, by Telecom Italia Mobile TIM in Torino, by Orange in Paris, and Telefonica in Madrid, and there are more sites globally in the US and in Asia joining the effort as well. We are focusing on the multi-vendor interoperability of all of the O-RAN components, the radios, and the distributed and centralized units in the background. And we're covering the transport as well as the network services and also some security aspects. So next, on the application realm, if you remember the introductory diagram, what are the different application requirements? The leading application areas these days are certainly the public use case scenarios of emergency services, of services helping with natural disasters, etc. So they are all well known under the term PPDR, followed by augmented reality and virtual reality use case scenarios, especially for factory and professional setups, not so much for consumers. Followed by V2X, vehicle to anything, like vehicle to vehicle and vehicle to services connections, especially not only for autonomous driving, which is probably still quite out a little bit, but also assisted driving, where cars or trucks are being driven in an automated fashion only when there's a special situation and it's actually a remote driving solution. So each of these areas has its own application level KPIs, key performance indicators and requirements. Each of these has their own language actually, and interfaces and protocols on the application layer. So each of them needs to be taken into account into a different way. There are also different types of operational risks and technology changes. So when we actually go into a specific domain, we ask ourselves first, like, what would be a risk that the network needs to mitigate. For example, in a railway scenario, when a shunting engine is actually remotely controlled and the connection fails, of course, the engine will probably stop, right? But still, it's a question, what does the network need to do? What are the minimum requirements on the performance, the availability, the latency, and so on, that need to be provided for a safe operation of the individual use case scenarios. And these kind of risks and specifics need to be taken into account for the application testing, but also for the testing even on the network layer to be ready for such applications. So in summary, in the public, you know, when I read some press releases, I sometimes feel 5G is done. You know, everything is beautiful, everything is running, everything is production, but that's by far not really the case yet. And of course, I'm a professional pessimist because I'm a tester. On the other hand, I know it's a very, very complex environment, and I have huge respect with all of the vendors providing solutions in this area. I think still it's good to be realistic, and it's good to be prepared for adequate testing environment for such a complex application scenario. So especially in the application integration, we still have a lot to do. We still have a lot of research even. And given the high frequency of software updates and the much more multi-vendor focus than in previous mobile network generations, it's clear from our point of view that regression testing needs to be changed. It needs to be automated. It needs to happen more frequently, but it also needs to happen at more centralized locations, because the testing challenges that typically have been shouldered by vendors and then demoed or POC'd, POC'd to service providers are probably no longer going to be sufficient. So our goal is to actually go towards a test as a service, lab as a service solution that can actually provide centralized, efficient, cost-effective, low barrier testing services required by the 5G networks and applications. Thanks very much for your interest.